gonna record. All right. Hello and welcome to the Ozeki Journal Club, Perry.
You're Carlos and I'm Perry.
I'm Carlos and you're Perry. Nice. Let me enable you the right to record. No, to share. I can't let you share your screen.
Host disabled attendee screen sharing. That's what I have on my side.
Huh. I'm gonna make you co-host.
That'd be sick.
So how's it going?
Not bad, you?
I don't know. I'm feeling like I'm in my cleaning up my thesis portion, and it's annoying.
Well, you're almost done, right?
I know, but it's like the last 1%. It takes 90% of the time, you know.
Well, you know, you have to go through it eventually, I guess, right?
Did you did you sort of have to think a lot about sort of phrasing and like how you want to like link together the concepts and all of that?
Like you're talking about the introduction specifically.
Yeah, that's the only thing I did. Like the rest, I just pasted together in my papers.
Yeah, so I think, but I think I did that in the beginning. Like I wrote it down, you know? Like I made blocks and like this block and it's connected to this block through this logic.
Yeah.
And then it's just clarifying that logic.
Yeah, I think that's
The annoying thing for me was after my corrections, I got back, one referee wanted me to change the motivation for something, you know?
What? Okay.
Like he's like, oh yes, like the motivation is quantum computers, but also like it's much more general what you did, so you can motivate with other things. And then the logic wasn't working anymore, you know?
Oh damn.
Because the logic was based on this quantum computing or quantum information thing.
Yeah.
So I had to change a bunch of stuff after the corrections.
That's a deep comment.
Yeah, it was pretty deep.
Well, I guess it was good for you in the end, right? Like that it was just making it stronger, right? Like you had he let you make a stronger claim than you made for yourself.
Yes.
I don't know if I'll be able to defend this semester though, which is annoying.
I think it is fine.
You think like when from the time you submitted, when was your defense scheduled?
I think 2 months later.
2 months later. Okay, then there's no chance.
No, but I had a buffer, you know.
Oh, okay, you submitted like 3 months before the deadline.
I think I could have submitted like 2 weeks or 3 weeks after, and it would have been fine.
Yeah. Okay, well, we'll see what happens.
I think I submitted end of May, and by end of June they had finished correcting it. But my defense was like mid-July or something.
Oh. Wait, you got back corrections after your first submission?
No, but like the referees were ready.
Yeah.
They just sent the report was dated like end of June.
Yeah.
But my defense was like mid-July.
Yeah.
And I submitted end of May or something.
Okay. Was your were you by yourself during your defense?
Yes.
Like was Vanessa sitting on the other side just watching with popcorn or something, or was she like doing something else?
It was on YouTube, right? So she was in the corner, like in another room.
Okay, yeah, because I was
watching.
Like talking about it with Victoria, and she's like, "Yeah, I'll be like next to you, you know, like because you could technically have like people there, you know, since
sure,
it's on
but
Zoom."
I guess I think it would. To me, it felt like it would be more distracting.
Yeah, I would imagine I might have to like impose some limits.
Yeah, flip the table.
I'm gonna go to my defense now. You go to your room. All right. Yeah. Let's do this. So we're back to blockchain today, right?
Back to blockchain. Found a nice short paper.
Did you look for this paper? Did you look for short papers to find this?
No, I looked at things that were, I guess, different related to blockchain.
Are you like a Google Scholar guy, or are you like a straight to the archive guy?
No, Google Scholar. I'm a Google Scholar guy.
Okay. Yeah.
So yeah, I looked at recent papers, and this is 2020, about blockchain. This came up. It seemed like a very specific application.
Yeah.
And I don't know. It looked interesting. It looked like it was quite short. They had a nice figure where they explain what they're expecting, and it reminded me of a project we try to do with the refugees. So I thought it'd be interesting to look at.
Yeah.
So this paper is called Towards Secure Smart Parking System Using Blockchain Technology. And the first author is Wessam Al-Amiri. And I guess it's a bunch of
Florida.
There's I guess I don't know if it works, I guess, in chemical engineering or whatever, electrical engineering, but the last author, if it's PI, is from Florida, I guess.
Huh.
Yeah, it's weird actually, because the first author is from Tennessee Tech, so I'm not sure how this works.
Yeah, it's like a Florida/Middle East collab.
Yeah, I don't know what these people actually do like day to day, or if they're blockchain people, but it looks like, I don't know, this looked interesting.
Yeah, you want to go full screen?
Yeah, absolutely. Is this better? I could probably zoom. I don't know how to zoom.
Yeah, you can zoom in. Just like with your fingers go, or Command plus.
Oh, I have a separate mouse. That's fine. Command plus. Is that too big? That's fine, right?
That's perfect.
Okay, so yeah, so this paper is about parking basically, and leveraging blockchain technology to improve the way people park their cars.
Parking is something nobody does anymore.
What do you mean? Like, you mean self-parking?
In the new world? No, like I used to drive to school. No, I don't.
Oh, I see.
I used to have to park.
Yeah, so maybe it's not very current. It seems quite current, but I guess people will eventually drive again to places.
Hope so.
What's interesting is they give a pretty nice introduction, according to, like, for me, like why this is an important problem.
Yeah.
So they discuss how, okay, so 1.3 million drivers struggle every day to find available parking spaces in Shanghai City, fine. But, okay, so this leads to traffic, number one. They also give some, so 30% of traffic congestions are attributed to the problem of finding available parking spaces. And then they also related to emissions. So in Los Angeles, 47,000 gallons of gasoline are consumed every year, and 720 tons of carbon dioxide are emitted, I guess, just from people trying to find parking spots.
Yeah.
So I guess the advantages of using something more efficient
I can relate.
Is one, reducing traffic, which is good for everybody, and two, reducing emissions, which I guess can't hurt.
You know what people might say though, if this paper had a statement like the last one we saw about like societal impact, it might say that like it incentivizes driving, and
I see.
I mean,
yeah, but
a lot of people don't drive because parking is annoying, right? And like if parking becomes a lot easier, then maybe there's an offset to like the gains.
Yes, maybe I should say that this paper is about trying to make parking easier. So the idea is you want to use a blockchain to have people that have parking spots available post their parking spots on this blockchain, and people can find parking spots more easily because they can just look at a blockchain and tell them where the parking spots are available.
Well,
so I guess maybe this would incentivize people to drive.
Yeah, no, but I would say like the contribution is going to be like the technology for automatic or sort of like a smart parking app or system is like an IoT thing, right? It's not like a blockchain thing. Like there's already systems that let you do this, but they're proposing an improvement, which is to implement that technology on a blockchain, right? But you could already have smart parking without any blockchain.
Oh yeah, I just wanted to give the overview of the thing they're trying to make.
Yeah.
And how it relates to people being encouraged to drive.
Yeah, that's true. That's true.
So the thing is here that so you're right. This for sure exists in some centralized way, for example, where you can just post parking spots online, and when people take them up, well, then you know that they're taken up, and then the next guy won't go park there.
I was wondering if this. I think maybe we'll get to it in a little bit, but I was wondering if it applies to parking spaces like on the street or to spots in parking lots, So
I think they mentioned that one of the people that can offer parking spots could be the city, for example.
Which also sometimes owns parking lots, right?
Oh, maybe. I don't know that actually, but okay.
Yeah, they do. Like, the ones that are like outside metros?
Oh yeah, that's true. But I don't see why it couldn't apply to the spots on the side of the street.
I was more curious for like these estimates, if they're like,
for consumption, you mean?
yeah, because I think I don't know, they talk a lot about parking lots, and like to me, it's not a parking lot is not the same as a parking space like on a street, you know, that's like parallel to traffic. And
I guess there are these parking spots on the street where you have to pay, right? Like with these meters.
Yeah, I guess you could consider that a parking lot.
Yeah,
which is very big.
I think those are the most sought after spots, though, right? The ones that have meters and the ones you have to pay for. Yeah,
exactly. That's why, like, if they're maybe not considering those, then maybe like these carbon dioxide estimates are like actually way higher. You know, like
I see.
Yeah. Anyway, I don't know. Maybe like it'll become clearer.
I'm not sure how these estimates. I just assumed it was just like you just estimate how many gallons of gas are used by people just circling places trying to find parking.
Yeah, because you also have like
regardless
IKEA,
of the spot.
Right? Like when you go to IKEA, it's.
Oh, I see. I'm not sure. Yeah.
Right. Then,
I don't think there's an IKEA in the center of Los Angeles, though.
That's true. But I read I didn't read, like I was like listening to a piece of like one of these like popular science books. I think it's called like Everyday Algorithms or something. And one of them was like, they're like, optimization is cool. Like you can use it every day. And they give like this argument for how long you should be looking for a parking space versus like when you should like settle for one that's maybe further away from the door. I don't have the answer for that, but it's a thing.
There you go. Yeah. Okay, so that's the idea of this paper is quite simple, actually. So the goal is, okay, the idea is to install these IoT devices in parking spots, which could detect the availability of a spot. I'm right here at the bottom here. And then that can send information to some parking clerk or whatever, or a guy that owns a parking lot. And then he would upload this to some blockchain, and then you can check on this blockchain if the parking spot is available, if you want to purchase some time in that parking spot, and all this stuff. You know, and the reason you want, sorry, go ahead.
You know what country has this?
I do not.
The Mexico City airport.
Nice.
Mexico's behind on a lot of things, but they do have like these detectors on parking lot spots.
Okay, because I don't know if they mentioned it here, but in the longer version of this paper, they talk about these ultrasonic sensors or something.
That must be it, yeah. There's these things, they're like on the roof kind of the parking lot, and they like turn red if there's a car there and green if there's no car. But I don't think there's any like I don't think there's any like application tied to it. Just like as you're driving, you can see like without having to go into, yeah.
Okay. So, but the idea behind this and why you would want to use a blockchain, because you can imagine this on a centralized system, right? Where you just have an internet website and like you just post some spots and when they become available and take them down when they're not. They talk about two things. Actually, maybe I'll, this is the longer version of the paper. I highlighted some stuff. So,
oh wait, Perry, you have to share that one because I don't see it. Oh no, wait, I see it. Ooh, highlighted.
Yeah, so,
does this paper, so this is a earlier / longer version, right? Does this one contain all the information the other one does?
It contains all the information and it goes into the mathematical specification, like the mathematically or cryptographic details about how they want to implement the different steps.
Okay.
Which I won't really get into because I don't understand them 100%, but I read this one first.
Okay.
Yeah, so I think the introduction is quite similar, but just because I highlighted, it's easier for me to track. But okay, so they say one major concern is the driver's privacy.
Yeah.
So with a decentralized system, so you know, if I know where each driver is looking for a parking spot, I can infer where he goes to work or she goes to work, where they live, all this stuff, because I know where they park their car every day at what intervals. So maybe I want to limit that information from being spread on the internet. And the second reason I want a blockchain. So, okay, this is something that I want. This is for privacy's sake, and they can, they have a way of, you know, eliminating that information from a blockchain. And the second thing is, okay, centralization. And they talk about things like, okay, I don't know how realistic these things are there, But they talk about distributed denial of service attacks, stuff like that. That I don't know. Single point of failure. I don't know how important this information is to people. Maybe if it's related to these this privacy stuff, it could be important. But okay. So the two things they want to use blockchain for. Okay, so one is they want to limit not just information but like identities on the blockchain.
Mm-hmm.
And two, the centralization. They want to decentralize it because centralization means single point of failure, denial of service attacks, and also, like I told you before, these sensitive information like name, email address that could be hacked from a central server.
I would imagine that they're kind of independent things, right? Like you could probably have a lot of privacy but still have a centralized service, and you could have a blockchain with very little privacy, right? Like,
but I guess you'd have to trust the centralized service.
Not necessarily. I mean, I don't know. I mean, maybe with some like zero knowledge stuff, you could like prove that you paid without sharing your license plate or something. Like, I think there might be some like fancy cryptography you can do where you communicate with the server that just says like, okay, this spot is fine. I don't know who's there, but I know that it was a valid transaction just by like directly speaking with the car or the phone. But it could still all live in a centralized server. And then you could also have like a blockchain where you just publish all your information. Like the fact that it's on a blockchain, I don't think adds any privacy. Like just the fact that it's on a blockchain.
Oh, I see what you're saying.
Right.
Yeah, I think there's just the thing about this protocol that I'll get to is that they don't think they don't envision a fully decentralized system. So there is a centralized element.
Yeah. Like with the validation and stuff, right?
Not just the validation. So I'll go back to the old paper, but not to the old paper, but the 2-pager. So you see here, that's just a setup, but now their architecture for the system is in section 2. They have this key distribution center, right? So this is a centralized service that links, I think, identities to keys, basically. So there is some centralized service that knows your identity at all times,
No, but I don't think that applies to the drivers, right? I thought that only applies to like the parking lot owners. It's like, okay, the government's like, you can own this parking lot, you're fine.
So you're right. From here, it looks like that. But I think from the longer version, I shouldn't hop back and forth there because maybe the longer version is too intense. But
it's really intense, eh?
The offline trusted authority, is initializing the whole system, including registering drivers, generating cryptographic public parameters, distributing keys, and generating public keys.
Oh, okay. I didn't read that in the short one at all.
No, that's fine. But I think you're right. I think in the short one, they don't discuss that at all. Like they
yeah.
Which is weird because it comes after. So I don't know why it's like, but you're right. From here, it looks like they just want to register parking lots.
Yeah, because I don't see a need for registering a driver. Like, as long as the person trying to park has made a transaction to that parking lot space.
How do you link the person that parked to the person that paid?
It doesn't matter, right?
I think it does, right? Because what if I pay for a spot and then someone just pulls into it?
Yes. Okay. That does matter. Yeah. Okay. So it's true. There has to be some.
I think so. Well,
yeah. You're right.
Maybe it's not a big issue though. Maybe it's not a big issue. I'm not sure.
I think it's probably a huge issue. Like that. What? I think that's probably a big issue with the privacy, right? Like the transaction that you make, the payment that you make has to include personal information.
Well, it could just be a key, right?
Yeah. Oh, it's true. Like if you show up and you scan something and then you're the one who's allowed to park. Yeah, sure.
Yeah.
Sure.
And then if someone's, Okay, let's stick to this and we'll get to the details if we want in the other paper later. But okay, so their architecture has a key distribution center, which is a government agency like the SAQ here in Montreal or Quebec that gives you your license. They register parking lots, say. Then there's a consortium blockchain, which is just made up of different parking lots or owners of parking lots that have this blockchain. And then Right, and the parking lots send information to this blockchain, and the drivers can look at the blockchain and buy spots for certain periods of time, rent spots for certain periods of time. Okay, and then the main difference between this short paper and this long paper is in the short paper they just focus on two, I guess, two phases of the architecture, or two pieces of this
scheme.
Sorry.
The scheme.
Yeah. So and it's quite simple, right? So the parking lot, the parking lot manager or parking lot owner or parking lot itself, maybe if it's an Internet of Things object, PL, just submits a parking offer onto the blockchain network. Okay, and then you have a city area, say, and you split it up into sub areas, C1 through CM. And
the city area, is the city area a parking lot?
No, so if they have a figure in the other paper, I'll show you. Oops. So it's just oops, page up. Yeah, here. So you have your full city and you just separate it into a grid.
Okay.
And the idea is you want to be able to hide which grid. So if I'm driving in grid C18, in the square of C18, I want to be able to hide that I'm looking for parking spots in C18. Otherwise, people could infer from that. If every day I park in grid C18, in the square of C18, they would know, for example, that my work is at C18.
Okay, but why does there have to be a geographical component to this? Like, couldn't you just have a list of parking lot IDs?
Yeah, you could, but I think the point is when you're looking for a parking lot, for a parking space,
you want to know where it is.
I just care where it is, right?
Right.
Like I'm okay parking anywhere in C18 because it's close to work, for example.
Yeah.
I don't want to but I don't want to park in C1. So maybe when I'm searching for parking spots, I say I want to search for C18, C19, C17.
But so within each C, there's a set of parking lots, right?
Or parking spaces, yeah.
Right. Okay, sure.
So when a parking availability is pushed to the blockchain, when it's pushed to the blockchain, okay, yeah. So you push the ID of the parking spot specifically. Okay, the location, I guess, is just some
like GPS.
Sorry.
Oh, I thought it'd be a GPS coordinate, but it's not.
Yeah, it could be, I think.
Oh yeah, okay.
CM is which grid you're looking in. And N gives you the available spaces. S, okay, they add this extra feature where like maybe there's a charging station for your electric car or a car wash that can also be put on the blockchain. How much it costs and how long it's available for. And this is just signed by the private key of PLJ, the parking lot, and it's put on the blockchain.
So only the owners of the parking lot can create these like offers.
Exactly. Yeah. People that are offering parking lots, not parking lots, parking spaces, can put these on the blockchain, these offers. And then there's validators that work. And what they do is just verify that the signature was signed, the offer was signed by the parking lot. Like the person that owns parking lot IDJ signed it, so with his private key.
That's cert, right? They just check cert?
Yeah, I guess so, yeah.
Yeah.
So they just check that the signature is valid for the owner of the parking spot. And then there's a secure consensus protocol that's run. And the example they give for this consensus protocol between the different validators is this Raft protocol that belongs to, it's like JP Morgan or something.
Oh, yeah?
Yeah, okay, I'm jumping back and forth. I'm sorry, I'll give you the...
No, it's fine. Joe Rogan style.
Where is this? I can just... Raft. Yeah, JP Morgan.
Hey, Jeremy, pull that up, will you? Okay.
So the consensus nodes run the Raft consensus algorithm, which is used in Quorum blockchain of JP Morgan bank system.
What? That's pretty cool.
Yeah. We can probably look at this here, maybe for a future episode. Right. Okay. So there's some consensus between different validators that they have to achieve to make sure that this offer is valid. Okay, and then the second part of this is if I want to buy a parking spot, right?
Mm-hmm.
I can just look at my smartphone, say it can access the blockchain, but I want to, they talk about cloaked cells here. So cloaked Cs. So when I'm searching, so the driver D sends a query to the slot leader of the blockchain network in order to download all parking offers in the desired cloaked cell.
So the slot leader is like the guy who has the official records, blockchain, right?
Yeah.
Okay.
Yeah. So well, from my understanding, yeah. So you'd be driving, say, in a region C5, and you want to park there. You want to be able to send a query to the blockchain or this leader and have him respond without knowing which cell you're looking for. And they talk that note that retrieving the parking offers is in a cloaked cell preserves the privacy of the driver's desired parking location, right? So if no one knows what cell you're looking for, then no one knows where you want to park. No one knows where you're going every day. Okay, and then after retrieving this information, you can pick your spot for the time you want and pay using some cryptocurrency on chain. For example, Bitcoin. Okay, and this seems like I just wave my hands because how do I get a cloaked cell and all this? And that's explained actually. There's no reference to that other paper, but it's explained in that other paper. Their scheme for doing this.
Nice.
So here they just talk about it like it's some obvious thing, but okay, it's a bit confusing. It's a bit intense what they have to do to get that.
So like this figure 1 here, I guess we covered it, right?
Yeah, so right. So you start with your key distribution center that registers parking lots. And what this distribution center, I imagine, just gives them access, these parking lots access to be able to post things on this blockchain. So they can, each block has a bunch of offers in it generated by each of these different parking lots. And then as a user, I can look up this blockchain, query it, and I can query for offers that have specific information in them, like this CM identifier. So I can say I want all offers that have parking spots in C5. And then once I book one, I can do that by sending a transaction to the parking lot in Bitcoin, say. And that should automatically book this spot and remove it from the next block of the blockchain.
Yeah. I would imagine, maybe we're going to talk about the cloaked cells thing next, but I would imagine you could have some kind of correlation attacks happening, right? Like if you see someone's like balance go down and then you see like a parking lot owner's balance go up, whatever, I don't know.
We can talk about this now, I guess, but the idea, if you look at the other paper, is that when you register for the, in the other paper, you have also like a lightning rod between the drivers and this CDC, KDC. And what they provide you with is, it's really cool because there's a way apparently to, well, we've discussed this for this refugee project, but they can generate you with keys that allow you to generate an infinite number of private and public keys.
Okay, yeah.
So then every time you book a spot, you can sign it with a different public-private key pair.
Isn't that just like a hierarchical wallet or something?
Yeah, it's a bit weird. It's not exactly that. There's a bunch of math involved, which I didn't go into in super detail. Yeah, it's right here. So I can probably zoom in a bit more if you want to see this. But I don't know if this is big enough for you.
Not big enough for me.
So it's right here.
That's what she said.
Okay. So the driver D can register with the TA, which is this trusted authority, to obtain her credentials as follows. She generates a secret key by randomly selecting, some number. Anyways, and there's this whole procedure with the signatures involved. And at the end, you get the trusted authority stores 4 things, including your ID, and returns you with these 3 things. And then you have a group secret key, which is these 4 things, A2 being something you generated yourself, this selected randomly generated thing. And these 4 objects allow you to sign things with different public and private keys every time you sign.
Okay.
So I don't know how I can show you that.
So how does
sorry, it's not here. It's
So you can't just generate your own key pair, basically. There's like a set of valid keys, even though they can be generated.
Okay, yeah. Again, I didn't understand this fully, but I assume that there's some level of randomness, because you see the driver driver randomly selects A2. That's part of the key. Yeah. But these sigmas associated to you are generated from these other things that the trusted authority knows about.
Okay.
And then the second part of this is also that if in this phase, so this is parking offer retrieval when you want to look for parking spots. The driver D wants to retrieve the parking offers in the Dth cell, so CD, from the N blockchain nodes without leaking any information about the identifier of the request SLD. So they have some other way, which again seemed a bit complicated for me. This Reed-Solomon. Sorry, I went up too quick. Actually, it skipped a lot. Sorry. Oh. This Mac doesn't respond to my going up and down stuff.
Because you're pressing page up and page down. No one does that.
What should I be using? I'm trying to scroll.
I don't know. Up and use the keypad, the trackpad.
Okay. I don't even know where I am anymore in this paper.
Proposed scheme. Byzantine.
Yeah. Okay. So here they also analyze. How many nodes can be like corrupt, for example.
Okay. Wow.
And I can't find where we were before, and I keep scrolling up and down. Okay. Anyways, let me get to the point of this. Let's finish this 2-pager, and we'll get back to this after.
Yeah.
Because this paper ends with a brief description of how much the consumption of such a protocol would involve. So they talk about storage cost overhead, and I think also they start with storage cost overhead, and they talk about how many bytes it would take per node and all this stuff. And actually, I shouldn't have closed the other paper because the other paper has the graphs. That I can show you guys.
I feel like that other paper was some kind of like abstract, like an extended abstract for a talk or something.
Maybe. So you see if the number of parking offers per cell, that's on the x-axis here, and this is how many communication, how many kilobytes of information have to be transferred between my smartphone, say, and the blockchain.
Okay, so it's linear.
So it goes to up to 4 kilobytes if there's 100. Yeah. And here, this one looks exponential, and this is the number of blockchain nodes and the communications.
Okay.
So they've done some analysis of
like the scale.
Because if my smartphone has to download like 10 gigabytes of info.
Yeah.
Then it's ridiculous. But it turns out that all the mathematical sequences or all the mathematical manipulations they have to do to implement all these hidden searches and private key signings and stuff only take quite limited amount of communications to transfer back and forth.
The order of kilobytes.
Yeah.
Yeah.
Which makes it quite nice.
Huh. It really is interesting that there was so much math in this. Like it seems like they would have just pulled things off the shelf for this kind of thing, right?
Yeah. That's what I thought was also going to happen. And they kind of do, but they talk about this Reed-Solomon code.
Yeah.
But they actually go into some details about like the polynomial and then using a ZK snark to make sure that you're actually parking in the right spot.
Okay, but I guess all of this stuff is like none of this is like new cryptography, right?
No, I don't think so.
Yeah.
But what interests me a bit was also like this initialization system, right? Where we talked about this, we had this project with these refugees. Where like maybe you have a central authority that gives a person a private public key pair.
Yeah.
That central authority is trusted, and then that person can then use that private public key pair to submit things on a blockchain. And it wasn't actually just for the refugees; it was also for this pair project, right?
I think it was more for the anonymous peer review, right? Because you want to be able to. I think you wanted to like hide, you don't want to link transactions to each other.
Yeah.
But you want to make sure that the transactions are being made by like members of the network, right?
Right.
So I would imagine this is what they're doing. Like you don't want to have like a repetitive use of the same approved like public key, so that you let them create a new one every time they use the system. But you also block against someone just spamming and creating random ones,
Right.
and like joining the network, right? But yeah, I mean, it'd be cool to like take the time and look at this. At the
Yes,
math
yeah,
here.
it would. But I think it requires a lot of background. Like, we would have to read a lot of stuff, I think. Maybe
Yeah.
not. I'm not sure.
Well, maybe we'll invite the authors.
Yeah, if anyone knows how to explain this to us, they're welcome on the show, I guess.
Well, I mean, it's funny because this is something that we talked about with Claude Crypto, right? Remember?
Did we?
A few years ago. I mean,
I think it was supposed to be more general, but yeah, maybe.
but we got to the question of like, we want a system where you can generate and
Yes.
you'd be able to generate new public identities, right, from a single private one.
But I think his argument to us was that you could do that very easily, but every time you use it, you lose some privacy, and like you use it, you lose some secrecy in your private key, right?
Yeah.
It gives an attacker an extra data point to try to crack your private key.
Mm-hmm. Mm-hmm.
This seems like something a bit different, right? Where you're interchanging information with a trusted authority,
Mm-hmm.
and they give you some credentials that certain people can verify these new private keys, these sigmas.
Mm-hmm.
I wish I should find like where they talk about this though, but
I mean, I don't know. Maybe I'm thinking about this in a really stupid way, but like, if you agree on like a function, like a polynomial, secretly, and you say, I will accept, you can generate points as your key pairs using this polynomial.
Yeah.
And whenever I like see your key, I will see if it comes from this agreed upon function, right?
Isn't this argument though against like having a publicly open, like an open system versus a closed system?
I'm not sure.
Like crypto in this cryptography class we took was saying that like it's better to have a system where everyone knows the rules, and people can try to break it, over having a system where people where you hide the rules and hope no one finds them out.
No, I mean, I think like it would be a public system, but there's some sort of like a key exchange step, right?
I see. Okay.
And like you go through this key exchange procedure with the trusted authority.
I see.
And there's some kind of secret, like it's not public. This exchange is not public, so you have a secret coefficients to some polynomial that only you and the trusted authority know.
Yeah.
And then you can use that polynomial to generate keys, right? And
so it's something like that, right? Because you see like the trusted authority randomly selects a k element of ZP to compute these sigma Ds, and then they give those to you. And then at the same time, you've selected some A2 randomly from the ZP.
Yeah.
Like there's a bunch of, so there is, you're right. It's something sort of like a
key exchange that
some key exchange.
It's like a generator, right?
Yeah, exactly.
But is there something in there about the step where you actually like generate a new key, or like when you go to a new parking spot?
So they talk about here.
It verifies the signature by checking.
Yeah, parking reservation phase. First, the driver D generates a fresh public private key pair.
Yeah.
PKD, SKD.
Yeah.
And sends the reservation request. You see, and then they can use these sigma Ds to check.
Yeah, exactly. Okay, cool. So that.
Yeah, then you verify the signature by putting these sigma Ds into some functions, H, hashing it, I guess.
Mm-hmm.
Yeah, so you're right. It's some sort of key exchange at the level of trusting an authority up here.
But the sigma Ds, though, are they unique to the user?
Yeah, so I think when you go to the trusted authority, it selects this K.
Yeah.
And these sigma Ds are sampled from this thing. Right?
Okay.
So for I'm guessing for every different user or driver,
the
trusted authority generates a new K. You've generated a new A2.
Yeah.
And then they generate your yeah. So this is a driver dependent quantity, right? Sigma D.
Right. So then when you generate a key pair and you go ask for parking spots, you need to tell the parking lot like who you are in a sense, right? So that it knows which sigma Ds to use.
I don't think the park. I think it's just the validators, right? I mean, we could
The
read this more
validators.
carefully.
Okay. A temporary
so-
PKD, right?
Sorry.
They generate a temporary PKD. You
Yeah.
highlighted,
So I think the point is all the parking spots have to do is care that the public key matches the private key. Like if you just signed it, right?
Okay. Yeah.
You post some public key on the blockchain.
Yeah.
Signed by a private key that matches that public key.
Yeah.
And then they don't care as long as like you've signed the transaction properly.
Yes. Yes.
And they get paid, I guess.
That's true.
Yeah. So you see, you take your sigmas, you pick some random numbers,
mm-hmm.
and then generate new sigmas from those sigmas.
Mm-hmm.
You know, by doing this procedure.
Sure.
And then hashing that. Like I don't understand exactly how this works, but there's some cryptography in the background that lets you randomize.
So the bottom line of that is
it's the short randomizable signature scheme.
Mm-hmm. Yeah. So you want the system to be able to authenticate you without being able to like have a history of where you've been, right?
Exactly. Yeah. So the way they achieve their goals, right, is one, like you said, right now, right? If you have these different public keys and private keys for every transaction you make,
mm-hmm.
no one can ever correlate where you've been with where with
mm-hmm.
your identity.
Yeah.
And two, they also have this other system, which we haven't gone into, but apparently is almost off the shelf,
mm-hmm.
where so you can query the blockchain for some region of space.
Yeah.
Without giving any information about what the region of space is.
Oh, right. Yeah, that we didn't really get into, right?
No, but again, it involves these query polynomials.
Okay.
And
maybe next time then.
Yeah.
Cool.
So it's doable, and then if you just take that for as fact,
yeah,
then they've achieved their goal, I guess, of creating a system where you can park a car in a parking spot without giving up any information about yourself,
mm-hmm.
And it's decentralized, basically.
Mm-hmm. Yeah, I still kind of, I'm not sure why like they need all this fancy stuff though. Remember Slockit? Like the locker
yes.
Service
yes.
there. I mean, I would imagine this is like almost exactly the same thing, right? And isn't it like, I mean, I don't know if we need to go over Slockit, but I think it was like this, they have these lockers and like they open up if it just locks, right?
And if you send enough ether to some address,
yeah,
they open.
Yeah. So, I mean, you can think of the parking space being available or reserved as a lock, right?
I think it's slightly different though, because in the ether case, one sec. So I guess if I'm parking in the ether case, I don't care. I think if everyone knows that a certain public key keeps opening a lock, right?
Sure.
Okay, maybe you would care. But I guess I can always generate my own public key, a different public key for every transaction.
Yeah. Mm-hmm.
But here, I think the point is you also want to associate your driver's license or your car to some identity, right?
Do you though? Like, I'm thinking let's say every time you park, you create a random public-private key, like not this like generated thing. Okay. And then you send a transaction to that parking space, right? You send some Bitcoin to that parking space. Mm-hmm. Now, like maybe your like car has this some kind of device that can sign transactions for that public key, and then when you pull up, like you just like transmit a signature. You just have to you have to basically sign a message using that public key that you paid with, right?
Or else what happens? Like,
I don't know, like some alarm goes off and like the parking lot guy is like, get out. Like,
okay, so you're saying it won't matter? Like, yeah, I guess maybe it doesn't matter if your identity.
no, but you wouldn't need to have any identity, right? Like, you would just need to be able to like be signed. You would just need to be able to sign messages with the public key that you paid with, right? They don't need to know who it is or anything. Like, it's just, that's the check to see that that parking space,
You're just
space
saying
has been paid for.
do slock it here, basically.
Yeah, I think so.
Where, if you send enough money to some address,
Yeah.
this parking spot becomes available.
It becomes available to whoever can sign with the address that paid for that space, right?
Yeah.
Right. So like if I paid for that space and you pull up, when you pull up, you're gonna have to like send a transaction to that sensor or whatever, or send a message, a signed message to that sensor. Like there could be some like question answer thing that happens, right? Over like Bluetooth or something that's like local.
But it could even be like it could even be like these parking meters where you have to scan your phone or something that generate the public private key.
Yeah, yeah.
And like it just verifies that you're the right person.
Yeah, exactly. So I think that would, yeah, I don't see why there needs to be like more personal information involved in this.
So let's see.
Maybe I'm crazy. I mean, I think if a government is implementing this, they're going to want you to put in as much like driver's license information as possible.
Oh.
Blockchains acquire Slockit. Boom.
Oh, it's slock.it.
Yeah.
Slock.it.
Italia.
It's weird, yeah.
Slockit got acquired.
Oh, it's actually blockchains.com now.
Yeah, yeah.
But what is blockchains.com?
I don't know, products.
Our products. Custody and management digital assets. Digital identity.
Yeah, I think they probably killed the locker thing.
Yeah, the development applications and ecosystems. Okay, well, yeah. Maybe you're right. Maybe these people don't know about Slockit. Maybe we should email them and tell them about Slockit.
I mean, I think they probably have some like engineering requirements. Like, look, the government needs to approve who can use this parking system, right? And like once that information's in the system, they need some way to like anonymize it, you know? But I think just like the bare functionality, I think you can do it with just random signatures, no?
Yeah, probably. Like, yeah, I guess. So your question is, what does this offer more? Like, what are you sacrificing identity at all for?
Yeah, I mean, initially I thought like at the beginning I was like, well, why do you need to like have your sort of personal information attached to these transactions? And you said, well, because you don't want someone to just pull up to a spot that you just parked in, right?
Yeah. That you just paid for, yeah.
That you just paid for, sorry. And that, I guess, I don't think that requires any personal information. I think it's like the same thing as saying, well, how come you can't spend the Bitcoin that I bought, you know? Like you're the only person that has the ability to sort of create signatures for a given public key.
Mm-hmm.
So if you yeah, like I generate random public key, I send a transaction to parking lot 52, parking space 52. I go and I like scan, I sign a message to, you know, I guess the parking sensor would ask me, okay, can you sign this? Can you sign a message using this public key? And then
yeah, and if you can't, the same thing that would have happened if you didn't pay for the spot at all would happen, right?
Yeah, there you go.
The police is called, or whatever the default is.
Yeah, exactly.
So maybe I'm thinking now, like, okay, this was like there's a grant from Qatar. Maybe in Qatar this is a thing.
Yeah.
Like they have to know who's driving every car at every time. I don't know.
Yes, although I mean, we didn't go too far into like their cryptography, right? Like maybe all of this. No, sorry. Yeah, I guess the trusted authority is going to have this database of like people's license plates and driver's licenses, right?
Well, it seems like that from the other paper.
And then it just doesn't get like accessed by the blockchain by like other members of the blockchain. And they also didn't talk about like, is this going to be a public blockchain or a private one? Is it on Ethereum?
Well, it's a consortium. They talk about that, right? It's controlled by the parking lots.
Okay, so it's a private blockchain. I mean, it has a finite number of members, right? Of nodes.
Well, it has a number of nodes that can access, like, that can broadcast transactions. But anyone can query it.
Okay. Yeah.
But not everyone can upload parking offers.
Yeah, yeah.
And then you see in this picture, they have a secret keys
Mm-hmm.
with a trusted authority, and the certificates of the parking lots here.
Yeah, I mean, I'm guessing maybe like, I don't know, if you're like some kind of terrorist and they don't want you to be parking, they can like ban you from the network, right?
Yeah.
Like,
no, maybe that's you can just still park. You can just still park, right?
How?
You just park, and then whatever happens. Like you don't pay for anything. If you're a terrorist, like the limiting factor is not going to be like, oh my god, I can't sign this private. It's like, I'll just park anywhere.
No, I meant like if for some reason the government wants to prevent you from using their service, they can do it in this setup.
Sure.
Right? Like, I don't know, maybe if you've had enough parking infractions.
But I think maybe it's also important. Okay, so I think we have to be careful. So here there's two things, right? One is you want to be able to pay for parking spots, fine. And that works in the Slockit case also.
Yeah.
We just drive up to the parking spot, pay for it, and it gets unlocked.
Yeah.
But now I also want to be able to query the blockchain. For certain regions in space.
Yeah, and you don't want. Oh no, sorry. Yes, that's fine.
I want that to be hidden somehow, right?
No, because if you're doing the Slockit unlocking, then it doesn't matter if someone knows that private key 5x31 was at location X. You know. If you generate a new private key every time.
No, but then you could still correlate, right? Because I have to give ether to that address somehow every time.
Yeah.
So I could just say this address, private public key pair, always funds in a private public key pair that unlocks in a parking spot in this region of space.
Oh, right, because you can always trace back the funds from one address to the other, even if you generate a new one, right?
Yeah.
Unless I guess you use some kind of mixer or some kind of
maybe that's the point. Maybe you have to use a mixer.
Yeah.
But I mean, it's you're just pulling the correlation one step back.
Yeah. I see. That's true.
So maybe it's something to do with that as well.
Could be. Very interesting.
Anyways, there's some interesting concepts here that we should maybe learn more about. Maybe Alessandro could help us with these.
Yeah, I agree.
But I guess maybe I'll just wrap up. So the idea here was to create a parking system, which is summarized by this.
A smart parking system.
Sorry?
A smart parking system.
Right. Where, parking lot owners can post spots onto a blockchain. And then drivers can query the blockchain without revealing any information about where they want to park. And the blockchain would respond with parking spots available in the region they do want to park in. And they can book those parking spots to park in for some given period of time. And this should reduce pollution by a certain amount of gallons of gasoline and tons of carbon dioxide, and could also limit traffic congestion.
And it would be it would have the benefits of sort of privacy and blockchain.
Right? So not only do you not reveal where you want to park, but you also don't have to reveal your identity to the whole world, maybe just to some trusted authority. Yeah.
And also, I guess this is a blockchain, so there's no there's a certain degree of transparency, right? Like the transactions are sort of publicly verified, and they're
they're verified by some validators. I think they have to be picked very carefully.
I guess they don't talk about that, do they? Like, do they talk about?
Well, they give some thresholds on how many nodes can be corrupt, right?
Yeah.
So they give some in this longer version of the paper.
Yeah.
They talk about people trying to mess up the blockchain. these nodes. So yeah, so n is the number of blockchain nodes. T is the colluding nodes.
Mm-hmm.
The thing is, I don't know why you would collude here. There's B are Byzantine nodes and R unresponsive nodes.
Yeah, I wonder if maybe there's some like price fixing that they can mitigate.
Maybe
like with collusion. I don't know.
Yeah, so I didn't go too deep into this paper, but superficially, that's the idea.
Yeah, so
And
if it's a
okay,
blockchain, though, like you should be able to check the transactions yourself, right? Like as a external person.
Yeah, I guess it depends if it's a public or private blockchain, I guess. Yeah.
Yeah.
But another result they have is the amount of data you have to store or communicate
mm-hmm.
through the internet to be able to implement the system, and it seems like it's quite small.
Mm-hmm.
Yeah.
Scalability, boys.
Yeah. I mean, they only go up to 34 nodes, which seems quite small to me, but okay.
Yeah, but it's what is the y-axis there? Communication overhead. It goes down, right, as you have more nodes, I guess?
This is an overhead, though, yeah. Yeah.
Yeah, so I guess, okay, so just more nodes means but less overhead.
I mean, here, yeah, okay, it's 100 spots per region. Yeah, I guess it depends on how. It depends on how finely you cut up this regional space.
Mm-hmm. Yeah. Very cool. Okay, well, so I'll email the authors. Maybe they want to hop on the pod.
Maybe, yeah. Can you give us more insight?
I mean, initially I thought it was like a really trivial thing, you know? And
it looks like that, at least from this version it does, right? It looks like this 2 page. It's like, yeah, we're just going to use a blockchain. People uploads, they upload offers and you buy them if you want.
Yeah. Yeah. But yeah, I think this is some kind of like poster or a short talk or something. I don't think it's a full paper.
It's a conference paper or something. I don't know. Yeah, so this is probably associated with some talk where they gave some probably more depth information about all this.
Yeah, for sure.
Oh, the scheme does seem different. Like if I compare this figure to this one.
Oh, I think there's a lag on your thing now. Oh yeah, that one. The lightning bolts and
the red lines over here. Like there's missing a connection here.
Yeah. I mean the shorter one's a year older, right?
Sorry. A year newer.
Newer? Oh, yeah. Okay. Weird.
This is 2020 and this one I think is 2019.
Same conference though.
Where's the conference?
Oh, sorry. Conference. No, I thought I thought they were different. No. Wow. Okay, well, thank you, Perry. That was very informative.
Thanks. And I guess next week, do we have an announcement for next week?
Yeah, well, we should be having a very exciting follow-up to our viral video, 38 views in 2 days.
Has anyone subscribed from that?
I think one person, yes.
Nice. We're up to how many subscribers? 8,
I believe.
On our way to 10. At 10, we do a giveaway. We do a giveaway at 10.
Oh my God. Yeah, it's things are moving. Things are moving. We're going to have the first author from the paper we talked about last time, which was the graph neural nets combinatorial optimization paper. So that should be really interesting. And yeah, I mean, we're recording that next Thursday. So I think, I don't know if we'll do any other episode before then. Maybe we should prepare for that.
Coming up though, the Erdos paper.
We're on. I'm liking our role, Perry. I think we're keeping consistent. Joe Rogan. That's what he says. You gotta just stay on it, no matter what. Drop content. The other day, I was looking at the house he bought in Texas. It's crazy. It's an insane.
Because he moved out of California, right?
Yeah, he got pissed at California. Like he was saying that they were the government was asking people to denounce their neighbors for having people over, during the pandemic.
Oh, really?
Yeah.
I guess that's true here too, though, right? The government kind of asks you. I don't know if they ask you explicitly, but I think it's kind of.
Do they? I never saw that. They always. I mean, their announcements always seem like really polite, Like, please help us,
Yeah.
And you don't. at no point do they say that it's like backed up by crazy fines or like I don't know, some kind of force.
No, I think if isn't it if you're too many people in the same house, you get some like $1,000 fine or something.
I mean, that's never in the announcement. I don't know.
Okay,
Like I never like dug into the policy, but at least when you see like whatever the premier saying like there's these limitations,
yeah,
it really sounds like they're inviting us to some kind of fun collaboration, you know.
be part of the community. Wear your masks.
Yeah.
Don't get together.
I mean, I guess they had their marketing people on it, but I think Joe Rogan got pissed about that, and he moved to Austin, to Texas, and he got this crazy huge mansion, just from putting out content.
But also less taxes in Texas, right?
No taxes
compared to California.
They don't pay taxes in Texas.
There you go.
Yeah.
Well, state taxes, I guess. Yeah.
And I guess federal taxes are pretty small, I would imagine. Like,
I don't know.
Yeah, Texas sounds cool. I don't know.
Also, isn't there a homeless problem in California right now? Like a bunch of homeless people in the streets.
I think there's. I think yeah, for sure. I think that's been around for a long time.
Yeah.
I watched this movie yesterday with Jennifer Garner, called Peppermint, which is basically the female John Wick. Like, it's marketed as the female John Wick.
Really?
Yeah. Which is like John Wick, but it's a girl. So, you know how like John Wick gets his puppy killed and he goes and like takes down the entire Russian.
This is a spoiler.
mafia.
You should have said spoiler.
Well, they marketed it as a spoiler. So John Wick means like someone gets wronged and they seek revenge and completely unrealistically destroy everyone. So Jennifer Garner does that. Yes, I should say spoiler. And anyway, it takes place like in California and in like the homeless village, Skid Row. That's pretty crazy.
I think a bunch of people are moving out of California right now. Ben Shapiro.
Oh, really? Okay, yeah.
Ben Shapiro,
I thought he would have left a long time ago. Where did he go to?
I think he's going to Florida.
Okay.
I don't know that. A bunch of people are going to like Nevada, I think.
Yeah.
You know the Hodge twins?
No. Oh, yeah. Are they black?
Yeah.
They're like sort of, and they have green eyes.
Yeah. Super. Oh, it's funny. They used to have a bodybuilding channel on YouTube.
Yeah, I remember them. Yeah.
Then they went to Bitcoin, like blockchain, like in the hype of Bitcoin. They were like called the crypto twins. And now they're like the conservative twins because they wanted Trump to win the election. They just changed their identity and now twins at the
end. Wow. Yeah, they know how to ride the wave. That's crazy.
Yeah.
Anyway, I think there's like a big decentralization happening though, from the corona. Like, there's less need to be in a hub city,
Oh, absolutely, yeah.
So that's probably why
I think downtown Montreal might die. Like,
I don't know. I mean, maybe we're being a bit like sort of thinking a bit too far ahead. Like, if the vaccine is out, like this was just like a 1-year thing that's like we're gonna forget about it.
But I think a bunch of companies realize that they can pay less money for real estate, and rent, and have people be just as productive working from home.
I wonder if I haven't seen like productivity reports,
Yeah, but you see all these companies doing like much better than previously. Like they're doing just as good as before, right?
Oh yeah. Okay, I didn't know that, because I thought like a few years ago there was a time where like tech companies were like, yo, let's just have everyone from home, and I think it ended up not working very well, so they went back to going into the office.
But one tech company, was it Twitter that said like everyone can work from home now or something?
I thought it was Microsoft, but I might be wrong.
Maybe Microsoft. I don't know. One of these big boys.
Jamie, you want to check that for us? All right, he's going to get back to us next episode.
Nice.
I can't believe Jamie though. Jamie is the craziest story. Like I mean, I don't know anything about Jamie other than he's a guy that Googles things. He's probably super rich now just from like being the guy that Googles stuff.
So like, what's his salary like? I wonder.
I mean, for sure he's super loaded. I mean, apparently Joe Rogan, the whole podcast I think is just him, Jamie, and he said like a few people that do like video editing. That's it. He doesn't have like anything else. So I'm sure Jamie's doing quite well for himself, and God bless him.
God bless him.
Have you ever listened to a full Joe Rogan episode?
No, it's
like a 3 hour. Slog.
I listen to the snippets on YouTube sometimes when they're interesting.
The snippets are a really good idea. Honestly, I wanted to do that for us, but I don't have the time for it.
Yeah, for sure.
But yeah, no, I listened to a few full ones. It's pretty cool. I mean, I think if you 2 times speed it, it's fine.
I 2 times speed everything.
Yeah. So I have NewPipe, which is like better than YouTube. You can 3 times speed.
Okay, is it comprehensible still?
It depends who's speaking. It's
Yeah.
borderline, but definitely 2.5. You can get up to that, and it's not too terrible.
I'll check it out.
People are probably like 10 times speeding ours. Like the average view time is 3 minutes. They must be 30 times speeding it.
Or not watching, maybe?
That's great. No, absolutely not.
Okay, I guess that wraps it up for this episode.
Yep. Thanks, Perry. See you next time.
Yeah, see you next time.